Hello, hello. We're back to the notes today. So you want to make sure you have your notes out. We're going into the next part of the chapter, and this is on coordinate geometry, it's called. Basically, we use a graph to help us learn things about geometry. So the first thing we have here, find the distance between the points 2, 6, and 7, 2. So I have them graphed for you. And we're going to do this two different ways. You might want to have a straight edge. Okay. So really we're trying to find what is the distance of that line. And one way to do this is to make this into a right triangle. So all right, so if we look at, we just call these points A, B, and C if we want. Okay, so now we have a right triangle. We can find the distance from B to C because that's the distance from 2 to 7, 5. And we can find the distance from A to B because that's 2 to 6, so that's 4. And then we can find the distance from A to C using the Pythagorean theorem, right? 5 squared plus 4 squared is, we'll call it C, equals C squared. So 25 plus 16 is C squared, so 41. And then we'll take the square root of both sides. So the square root of 41 is C. All right, well, we can also do this using the distance formula on the coordinate plane. So the distance formula says the distance between any 2 points, x and y, any 2 points, x1, y1, x2, y2. It's based off of the Pythagorean theorem here. Because notice that this right here, this 5, we found this by taking the difference in the x coordinates, 7 and 2, right? So by taking the difference in the x's and then squaring it, we got 25, right? So this would be 7 minus 2. Well, it doesn't matter which order you put them in because you're squaring them. So if you do 7 minus 2 or 2 minus 7, it doesn't matter. Negative 5 squared is 25, 5 squared is 25. So that gets this number here. And then over here, same thing. We're doing y1 minus y2 squared. So that's, in our case, 6 minus 2 squared. And that gives us 16. That's right here. So that gives us a distance formula. So the distance between any 2 points on the coordinate plane is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Now, like I said, it doesn't matter the order you put the x's and the y's in, because when you square it, you're going to get the same answer. Just a word to the y's. It's the way the calculator works. If you do -5 squared, it's not going to give you 25. It's going to give you -25. And the reason why that is because the calculator is doing order of operations. When you do -5 squared, like I just did, what the calculator does is it's doing -1 times 5 squared, because the negative on the calculator is basically taking -1 times 5. So it's doing order of operations, and it's saying we're going to square the 5 first, because exponents comes before multiplication. Then we're going to multiply by -1. So what you need to do is you need to put the negative number in parentheses, and that tells the calculator first multiply -1 by 5 to get -5, and then square that, and you'll get 25. So don't make that mistake. Right, if the bottom left edge of a rectangle is on point 0, 0, prove that the diagonals of the rectangle are congruent. So we're gonna have to draw a graph. Normally I'd hand you out some graph paper, but that would probably take all day for me to drive to all y'all's houses. So we'll just draw a little graph here. Okay, so if the left edge is at 0, 0, then we'll say this point is at A0. We don't know what X value is, but we know the Y value is 0. Similarly up here, we don't know what the we know the X value is 0, but we don't know what the Y value is. And so then this point here is going to be at AB. Okay, there's my rectangle. Now the question is, prove the diagonals are congruent. So we're going to use the distance formula to do that. So if we look at the diagonal 1, we'll call it, this one here, to find the distance, we'll take the change in the x's, so a minus 0 squared, plus the change in the y's, b minus 0 squared. Right, so the x coordinates a and 0, the y coordinates b and 0. And so we end up with that distance of the diagonal 1 is the square root of a squared plus b squared. And that's as simple as you can get that. This does not equal a squared plus b squared with no, or sorry, does not equal a plus b. The square root of a squared plus b squared is not a plus b. So I'm sure you remember that from algebra. So diagonal 2 now, over here, change in x's again, x1 minus x2, so it's a minus 0 again. And same thing with y's, we get a b minus 0. And like I said, you could do 0 minus b if you want, but when you square it, it's not going to make a difference. So this is also a squared, because a minus 0 is a squared. And then negative b squared is b squared. So since the distances are the same, we have shown that the diagonals of a rectangle are congruent. All right, so if you want a challenge, and you should want a challenge, you can pause the video and try to do this proof before you watch me do it. Because that would be kind of a test if you're kind of putting together the indirect proof stuff we've already learned and then the distance formula. But, all right, so we are given E is 7, 1. F is negative 3, 5. And G is 4, 7. What we're trying to prove is that they're not on the same circle. So we will show points E and F are not on circle G. Let's just keep going. Using, you could say, an indirect proof, or using a proof by contradiction. So now we got to assume the opposite, or the negation, of what we're really trying to prove. So we will assume that points E and F are on circle G. And then, of course, we'll be looking for a contradiction. So what does it mean for points E and F to be on circle G? So by the definition of circle or radius, our book puts them together. FG must equal EG, right? If F and E are both on circle G, then the distance from the center of the circle to those points needs to be the same, because they would both be radii of the same circle. So by the definition of circle radius, FG equals EG. So then let's use the distance formula to see if that's actually true. So by the distance formula, right, so let's look at F, distance from F to G equals, so change in X values, -3 and 4. So -3 minus 4 squared plus change in Y's, 7 minus 5, or 5 minus 7, however you want to do it. If you're a positive person today, you could probably do 7 minus 5. If you're feeling a bit negative because it's a Monday, maybe do 5 minus 7. So -3 minus 7. Sorry, -3 minus 4 is -7. -7 squared is 49. 5 minus 7 is -2. -2 squared is 4. So, and then that's under the square root. So FG equals the square root of 53. Okay, now EG should be the same. So EG, 7 to 4, so 7 minus 4, 1 and 7, so 1 minus 7. So 7 minus 4 is 3, 3 squared is 9, and 1 minus 7 is -6, squared is 36. So each distance from E to G is the square of 45. So because the square root of 53 is not equal to the square root of 45, this is our contradiction. Right? So we assume that the 2 points are on the same circle. We showed using the distance formula that they're not the same distance, therefore they both cannot be a radius. So we have the contradiction, right? The two things can't be true at the same time. They both can be on the circle and have different distances at the same time. So this is our connect. So we say, therefore, our assumption that F and E are on circle G is false, proving that F and E are not on circle G. Which is what we're trying to show, right? Prove that E and F do not both lie on circle with center G. And we did that. Okay, so here's some homework to try from section 11.6. And if you have questions, let me know.